Okay, so this one's going to be some basic integration because I have to explain basic stuff from time to time. So let's go ahead and do that. So part A, we want dy dx. So there's no reason to memorize that many formulae. So, and no one's gonna memorize the inverse trig functions derivatives or like, integrands. There's no reason to memorize all that because it's time consuming, so we could just derive it during our exams. So I'm gonna do it that way as well. So obviously 2 root x is cosine y, which gives us x is 1/4 cosine squared of y, and dx dy is 1/2 cosine y and then negative sine y. So dy dx is 2 over negative 2 over sine y cosine y, and cosine y is 2x, implies sine y is root of 1 minus 2 x squared. Just this triangle right here, which means, and Pythagoras theorem, just very basic stuff, is 1 root 1 minus 4x. So negative 2, so we have root x, root 1 minus 4x, and negative 1. And that's it for part A, quite simple. Part B, well, this is just some basic by parts. So we want integral of y dx, frankly speaking, is just integral of this dx, which means we have x to x minus x differentiating arc cosine of 2 root x. Just basic by parts, anyone could do this. Minus, well, we've already differentiated y once, so we could just say this is root x 1 minus 4 root 1 minus 4x dx because of part A, and that's it for part B. Very simple as well. Part C wants us to do some, well, frankly just gave us a hint for no reason. Excuse me. So we want to solve that part from 0 to 1/8 of whatever this is equal to, well, we want x is root x is whatever that is. So that cancels, so dx is negative root x sine theta d theta, so dx is also 2 sine theta cosine theta d theta, and yeah, it's 0 to 1/8, so obviously x equals 0 implies theta is pi/2. X equals 1/8 implies theta, well, 1/8 rooted is 1/2 root 2, so it's root 2/4. So cosine theta equals root 2/2, so it's pi/4. Theta is pi/4. So this is pi/2 to pi/4 of root 1 minus 4. 4x is 2 root x squared. So 2 root x is cosine theta squared is cosine squared theta. So 4x is cosine squared theta. 1 minus that is sine squared theta. Root is sine theta. Root x is, well, just that. And then negative 1/2 sine theta cosine theta d theta. And these cancel, So we have 1 over 4 from pi over 4 to pi over 2 of cosine squared theta d theta. And that's it for part C. And part D just wants us to finish the integration. So from 0 to 1 over 8 of arc cosine 2x dx is obviously we use part B as well. So that's x arc cosine of 2 root x from 0 to 1 over 8 plus this part, which is that, which is this, and well, any toddler would know this. Oops, excuse me there. Any toddler would know that. So first part is just 1 over 8 arc cosine 2 times root 1 over 8 to root 2 and minus 0, of course, plus 1 over 4 of times 1 over 2, so that's 1 over 8. And 1 plus cosine 2 theta is theta plus 1 over 2, excuse me there, 1 over 2 sine 2 theta from pi over 4 to pi over 2. And this bit, well, without the calculator, that's just arc cosine root 2 over 2. So that's pi over 4. So we have pi over 32, excuse me, that was some terrible handwriting. Pi over 32. And right hand side, oh, well, this bit, sorry. So that's just pi over 2 plus sine pi is 0. Plus, so minus pi over 4. And then let me think about this. Sine of pi over 2 is 1, so minus 1 over 2. And yeah, that's a weird one. That's a plus, so that's also a plus. So we have, that's pi over 4, and that's 1 over 1 over 16. So that's pi over 4 times 8, so pi, what? That's a weird one. Pi over 4 times 1 over 8 is pi over 32. So that's pi over 16 minus 1 over 16. And that's it for part D. Yeah, very simple.